Now today, initially I am going to just discuss about some basic operations on MATLAB. In the last class, we just let me write it down one more time here. So, as I mentioned in that last class, that given any kind of like if I write down anything in MATLAB, it is basically will be represented in the form of a matrix. So today we are going to look into some operations over the arrays in MATLAB. As well as what I'm going to do here is that today I try to explain that how we can write down functions in MATLAB, and we'll try to see that if we can plot some images. And these images, what we are going to plot today, we'll try to do it from that some data set I'll try to import from my computer, and from based on that data set, I'm going to plot. So let us see that how we go forward. So as I said just now, that as some of you are quite familiar with, that if I write down anything, any value in the MATLAB, like a is equal to 1, it is basically going to, if I go to my workspace, it is going to give me a size of a matrix of size 1 by 1. So now, so if I try to write down some arrays here, so I can do that quite easily. Like if I write down this 1:10, it basically means that this MATLAB is going to write down the numbers from 1 to 10. So if I don't mention anything between this 1 and 10, so it will mean that it is just simply going to add 1 with that integers, and it is going to give me the values from 1 to 10. So now next comes here is that if I do like this, like a 1, 2, and 10, so it basically means that I am giving that length of the interval between 1 and 10. So in that case, if I run it, so it is going to give me the values 1, 3, 5, 7, 9, and so on, like this. So this is very interesting operations here. So as well as if you see that, let me write it down here. Let's say I am writing down simply as b is equal to a plus 2. So if you remember that in the last class I mentioned that whenever you write down assign some new values to some variables in MATLAB, it automatically deletes that last value, and it takes that current value. So like as you can see here, initially I started with a is equal to 1. After that I mentioned a is equal to 1:10, and then I mentioned 1:2:10. So the latest is a is equal to 1:2:10. So now if you just look into here very carefully, it is just simply one matrix of form 1 row and 5 columns. So if you now just go to your workspace, you'll see that earlier values of a's have been removed, and that latest value, it is only being mentioned in the workspace. So which is 1 cross 5, which means only 1 row and 5 columns. So now if I do something like this, let's say b is equal to a plus 2. So what is going to happen is, with each of the values, latest values of a, which is this 1, 3, 5, 7, 9, with each of this element, 2 will be added. So that's why you can see here I am getting 3, 5, 7, 9, 2, 11. Similarly, if I write it like this, that b is equal to 2, so it is basically going to give me, so as you can see here, this a is 1, 3, 5, 7, 9. With that I am multiplying 2. So basically I am getting 2, 6, 10, 14, and 18. So this is how I can perform some operations over the arrays using my MATLAB. Also, you can perform many kind of logical operations over the MATLAB. So like as I say that let's say that I am considering two variables. Let's say now I am assigning some value 2 with the variable a. So a is 2. So if you remember that when I am putting this column here, it means that I am not going to, like in the first case when I mentioned a is equal to 1, since I did not mention this colon here, so it is going to give me the output. But whenever I am writing down a is equal to colon, it means that it is not going to give me the output immediately. So let me write it down. B is equal to 3. Similarly, after 3, I am having some colon. So now, if I mention that A equals to B, so now when I am writing down A is equal to, it means that I am assigning the value 2 to the variable A. Similarly, I am assigning the value 3 to the variable B. So now when I am writing down A is equal to B, it is basically going to give me the answer that whether 2 is equal to 3 or not. So as you can see, it's quite easy that 2 is obviously not equals to 3. So if you run it in the MATLAB, we can see that we are going to get this logical answer 0. So similarly, if I write it down here that A not equals to B. So as obviously, since in the previous case, we got the value 0 because it is not true. So that's why I'm getting the value 0. If I run this thing not equals to B, you can see that now A is equal to 2, is equal to 3. So obviously A is not equals to B. So the statement is correct. So it is going to give this logical 1. So similarly, like this, I can perform some logical operations over this arrow here. So as you can see that I'm writing down an array where the values are going to be from 1 to 10. So now if I simply write it down like this, A greater than 2, let's say, what I am going to get as output is that whenever the value of this condition, that is the value of the variable is greater than 2, so there the value in this array is going to be 1. In the rest of the places it is false, so it is going to be 0. So if I run it here, as you can see here, so I'm now going to get this 1 times 10 logical array, where as you can see for 1 and 2, the statement is basically, since the condition what I'm applying here, that is A greater than 2. So basically it becomes that for 1 and the 2, it is false. So you are getting the logical value 0. And then since from 3 onwards up to 10, your value is this argument of A greater than 2 is actually correct. So they have been replaced by this 1. So this is how you can perform some kind of operations. Also, there is one very good technique in MATLAB where you can replace these values in the arrays. So let's say I am writing down some this array from where I'm going to have these values from 1 to 10. So now if I say that I am going to replace the values of A where the value of A is greater than 2, and I am going to replace them. Let's say whenever the value of A is greater than 2, I am going to replace it by some number, let's say 39. So now in the previous case, in this case, as you can see, these ones will be now be replaced by this 39. So if I run it, you can see for 1 and 2, it doesn't matter now. But for in these cases, it has been replaced by this 39. So this operation, what I just now mentioned, what we performed for this array, we can also perform it for the matrices also. So let's say I construct a very random matrix of size, let's say 3 times 4. So now this thing is quite interesting here that whenever I run this command of this rank 3 and 4, it is going to give me this kind of matrices where the entries of this matrices, as you can see, they're in the decimal. But if I use this thing that rand integer, so in this case, the values what I'm going to get here is that, as you can see, these values or the entries in the matrix A is all of them are integers. So now, as just now I mentioned that I can replace any value of the matrix in this array, which is in MATLAB basically nothing but some 1 times 10 matrix. This similar kind of operations I can actually perform in matrix. So if I wish to, let's say, replace my value this A22, let's say now if you just look into here very carefully, this value is my 2 value, which means that the second row and the second column element. So which is 2. So let's say I wish to replace it by some say 100. So if I do that, now you can see the new matrix where this value has been replaced by this 100. So this is some kind of like some very basic operations in MATLAB. And this operation, what I am just now mentioning, that A is equal to 1 to 10 here. These operations, I am going to use this kind of instructions when I'm going to plot some curve. We'll get into it. So still now, whatever I have used here, I have not used this editor here, as you can see. This editor I have not used. So let us see some examples so that I can use this editor. So first, what I am going to do is that one of the easiest way to learn this editor is that so first of all, this whatever instructions I am writing over this command prompt, I can also write it then in the editor, and then I can compile them by using this run button. But similarly, I can write some code over this editor, and I can run them, and we can write down some program. So first, what I'm going to do is that how to write functions in a MATLAB. So the first thing what I'm going to do here is that I'm going to write down a function which is of where I'm going to have only one independent variable. So which is basically a function of the form y is equal to fx. So how I can write it down in MATLAB. So what I'm going to do is that I'm just going to write down function. Then let's say y is going to be certain kind of a function. So I have to keep some name to the function. So let's say I'm giving it some name. My function, it's a first function, and let's say it is going to be over the variable x. So the next what I'm going to do is that I'm going to write down the corresponding formula. So what is this my function x? So, and you can see I have only one independent variable, that is this x. So let me write down some a quadratic equation over this x. So I am writing down a very simple polynomial over here, and the way of writing down any kind of function here is that after you have mentioned this is how we have to write down this again. Y is equal to my function x, y is equal to the next line is going to be the y is equal to the corresponding formula of this my function 1x, because as you can see it is a function of x. So now I have to end this. So now what I have to do is that I have to save it. So let's say, as you can see, it is automatically taking me to the folder. So my function, and it will be saved in the form of a my function dot m. So let's say. So now, if I want to run it now in my command, how I'm going to do that? So let's say my function one. Now, if I say, now if I put some value to this x, let's say I'm putting some. Let me first do this. So if I write down my function 1, 2, as you can see, I can get the value of this one. So if I go back to that editor, so this, as you can see here, is my function. I have created a new function, which is my function 1, which is over this one independent variable, that is x, and this function is basically at the form x squared plus x plus 1, a very simple polynomial. So after writing this, if I save it in my folder, just by simply, if I just try to now calculate this value of this function at some value 2, if I just write it down as like this my function 1, 2, it is going to give me this value. So this is one very simple example, because this is, in this case, I'm just writing down a function which is only with this one independent variable, which is x. So similarly, like this, I can also write down functions of that multiple independent variables. And why we have to do that? We have to learn it because whenever we are going to discuss about supervised learning algorithms, that means we know that based on the different types of input in that variables, most of the time it is going to be strictly greater than 1. But based on that, I am going to get some output. So that's why it is very natural to write down a function which is over that, which is going to have more than one independent variables. So let me write it down. It is also can be written in that similar fashion very easily. So let's say y is equal to some, let's say my function 2, and let's say now I have to write down that independent variables. So in the first case, I have only one independent variable, that was x. So in this case, let me write it down as x over z, and the x and the z. So similarly, in the next line, I have to write down a function over the x and the z. So if I write it down like this, x square plus z square, and then I just simply end it. So now what I have to do, I have to follow the same process after writing down this function. I am just going to save this file. As you can see, it will be saved in my folder, that is my function 2.m. This file will be saved in my current folder. So now, if I just call this function in my command prompt, my function 2, and let's say, now in this case, I am having two variables here, 2 and 3, x and the z. So in this case, let's say I am writing down, putting the value of x to be 2 and the value of z to be 3. So what I am going to get? 30. Why? Because if you look into this function here, the value of x is becoming 2, so it's 4. The value of z is equal to 3, so it is going to give 9. So 9 plus 4, I am going to get is 30. So this is how I can very easily write down many very simple functions as well as many complicated functions in my pattern. So now let us get into that how I am going to because how we can visualize any kind of data. So that is quite important for us. So for that purpose, I'm just going to do that similar thing what I did in my last lecture. First, initially, what I'm going to do is that I'm going to import some data from my machine into that in my MATLAB. So first, what I'm doing is that I'm just clearing up this working space because I'm going to import this data into my MATLAB. So there is two ways to do that. So either you can just click this thing, as I mentioned in that last class also. I can just simply drag this here, and that will be very simply we can do this. There is one more technique that I'll go. So if I select this, so there is another way to import this data is that just click this. So you can do it according to your choice. So now what you have to do, we have to select this import selection. So as you can see, we have obtained this diabetes data set in our workspace. So now, since we are more interested into this plotting of this data, so let's see how we can first, in order to do that, let's see one more thing. So let's see, as you remember, this thing also we performed in our last class, that how we can separate these variables of any given data set. That actually can be done just by selecting this data set and from here just separate this variables. If you do that, you can see that all of the variables it has been separated in your workspace. So now, if we wish to like plot, let's say this age and let's say this BMI data we used to plot them. So you can see that we can plot them in many ways. So there is many options of plotting this kind of this age and the BMI as well from this data set. So let's say if I want to plot it like what we want to have some scattered diagram, what I'm going to do is just select this scatter. So anyway, I'm going to write it down the detailed code here just after a few times. So as you can see that just by doing this, I can have many types of plots. So before I go into that, this is how we can plot this kind of data set very easily. But before I go into all of these details, let us first look into that how simply we can plot many diagrams, as well as how we can label the x-axis, y-axis, as well as we can give some title and all of this. Okay, so first let me go to that. Okay, so let us first start with a very simple, try to plot some very simple graphs here. So now let's say what I had just now, that let's say my values of x are from 1 to 10, And let me give it some function. Oh, let's say this y is a function of x, and this x I can write it down as something like this: x square plus x plus 1. So now, if I wish to plot them, how I can plot them? So the command is very easy. Just simply write down this plot x and the y. You are going to get this plot. So now, so this is how we can actually plot many diagrams here. So let us get into some kind of let us take some interesting examples here. So let's say my value of x is something like, I want to do this because I wish to like explain this least format, because which is quite relevant for plotting these diagrams. Let's say I have been given some interval which is 0 and the 2 pi, and I want to, in between this 0 and the 2 pi, let's say I am having 200 points, and these points are actually individualized. So that I can do it just by writing down this least command, and inside the bracket is, you can see we are going to have these 3 entries. The first 2 entries are basically giving me the end points of the interval, that is 0 and the 2 pi, and this 200 actually mentioning the number of points what I am going to have with 0 to pi. So similarly, like this, let us see that if I wish to plot a very well-known function, that is sine of x, how it is going to. So this is basically going to give me this values of this x or y's. So for these values of x inside the interval. So now let's say I wish to plot them. So x and the y. So you can see I am getting very nice sine plot. So now let's say I want to change this curve little bit. Let's say I am having some y1, which is sine of y's of x. So now, if I want to plot them, what I'm going to do is that so let's say x and the y1. If I do that, it is going to give me, if I just press enter, it is basically going to give this curve of sine of 2x. As you can see here, that the previous diagram of y is equal to sine x, it has been removed, and it has been replaced by this y of sine of x. So let's say I want to plot one more curve, which is this, let's say sine of 3 and x, and the values of x are the same. So if I try to plot them for that given values of the x, so x comma y2, what it is going to give me is that it is, as you can see, that now we are going to get this. So now if I want to compare this curve of y1 and y, how I can do that, because in this case I am just simply getting only one curve, which I am doing the latest, that is y2, what I am trying to do. So in order to do that, if I just use a very simple command here, let's say y is equal to my sine of x, let's say instead of writing down, because I have already written them, so plot x, y, colon, then if I use this thing, this command hold on, and then plot of x, y1, and then again hold on, and then plot of x, y of 2. So if I just run this code, what we are going to get here is that I am going to get these 3 curves together. So this is how we can actually, so if we want to compare these 3 curves, we can simply just do this just by writing down this command of hold on. So as like this hold on, you can like in this case, in this plot, as you can see that the name of this x variable and this y variable, as well as what you are plotting basically here, that is not mentioned. So that you can do here very easily just by writing down that, let's say you want to give some x label. If you write it down like this, so it is basically going to give you so if I write it down that x axis. So what is going to happen here is that if I just run this code here, so it is, as you can see, that x-axis, it has been just been shown in this diagram. So similarly, if I just write down y level, so since you are plotting different variants of this sin x curve, so if let me write it down as this sine of x like this. So what is going to happen here is that, as you can see in the y-axis, I'm getting sine of dx. So similarly, if I want to give some title to this plotting here, if I just simply write it down that.
Hello, Prithwineel sir.
Yes. Tell me.
Sir, actually, you are not sharing the whole desktop, so that's why that complete that none of the plots we can see. We just see the command.
Okay. Just one second. Okay, right. Okay, can you see it now?
Yes, sir.
Yes. So, okay. So now I understood that. Anyway, so okay. So I think I have to go back and forth for this. Just give it a second. Okay. So now if I presence of, if I write down at as like this, that side x sine of 2x and sine of because this is what I want as my title. So if I run this thing here, so I'll share that diagram. So you can see it here that in the title I am just having this comparisons of sin x. So this is how, just by writing down like very simple code, we can plot very nice thing here. Nicely, we can plot any kind of curves here. As well as so now in that last diagram, sorry. So now, if you look at this diagram here, so if I now try to identify that what this blue line, what this red line, and what this orange line is actually describing, so that I can do it just by using one more very simple command here. So if I just simply write down this legend and compile it, we'll see that we are going to have a diagram like this. So if you see here in the previous diagram, before writing down this command, I did not have that what this blue line actually representing, what this red line, and what this orange line is representing. But if I use this simple command, it is going to give me that from the data set 1, this blue line is going to represent my data set 1, or this red is my data set 2, and this orange one my data set 3. So this is how we can plot very easily, and we can also include many information inside the plot just by writing very simple this MATLAB code. So now what I was planning to do here is that let's see what I can do it here today. So what I was planning is that I was just planning to discuss about this card fitting thing. So
hello.
Inside my this workspace, as we can see here, that I have separated this variables. So now, if I wish to to understand that card fitting thing, so how I can do this using MATLAB. So for that purpose, what I have to do is that I have to go to this apps over our screen here, and as you can see here that we have a very nice option of this card fitting. Just click. So after doing that, what you see here is that here you'll see that variables, what you want to plot, or you will see over this x-axis, y-axis, and z-axis. So let's say if I want to plot this my x-axis data as my age, and my y-axis data to be my blood pressure, and try to understand that how we can, based on this, we can find out some relation between them. So that I can do just by having, if I just select these two variables, it is going to give me this very nice line, which is basically going to give me a fit for this data set of age and blood pressure. So now, in this case, if you look into here very carefully, the polynomial what I am getting here, based on which I am drawing this, MATLAB is basically drawing this line here, this blue line in the diagram, that is basically this fx is equal to p1x plus p2. So as you can see, it is a polynomial of degree 1. So just by changing this degrees, so after selecting this degree 2, you have to click this button of fit.
That Windows is not visible.
Sorry,
That triggered Windows you are doing, it is not visible again.
okay.
So if you just share your complete desktop, then everything will be visible. I think you just
Okay, I
shared-
think I okay. Is it now okay?
Yes, it's now. Yes.
So now, so as you can see now, I am considering a polynomial of degree 2, so which is p1 dot x square plus p2x plus p3. So I am getting a curve like this. So along with that, as you can see that when you are approximating or you are getting this kind of curves, you can also derive these values of p2, p3, p2 and the p3. These values are also, in fact, that confidence intervals of these values of these coefficients also is given automatically calculated by the MATLAB. As well as to understand this goodness of fit, you can see that this SSC, which is basically how we calculate this SSC, is nothing but that like the distance between this from this line to this plotted data and take the squares. Basically, like counting that count the error and taking their square, and as well as at the end taking their sum. So this is how we can calculate these errors, these cases, as well as we can just by taking some tool, we can calculate this RMS and as well as this R square and this R square. So if this value, this SSC value, if it is too large, then in that case, it means that this data set is actually not good. So there is the amount of error inside your data set is actually too much high. Similarly, just by looking at this R square, this is also a very good parameter to understand that what is going to happen. So this value of R square, it always remains between 0 and the 1. The more this value is towards the 1, it means that the curve is very well fitted. If it is towards the 0 or value is very small, it means that there is some kind of problem in your data set. So anyway, so this kind of like in this, like instead of doing also polynomial, you can also do this linear fitting also. And for that purpose, you just have to click this fit and you're going to get this curve. As you can see that for the linear fitting, the model what you're considering here, that is this a times sine x minus pi plus b times x minus t square plus something like this. As well as these values of this SSC R square and all of these values, it has been given. So just by doing this simple thing, you can actually understand this study of this R fitting using this method. Also, let's say if I calculate now, let's say in that first variable for the x, I have considered this age. For the y, I have considered this blood pressure. So let's say that, okay, so this thing I should mention that in the previous cases, like in the case of linear fitting or maybe polynomial, that functions, it has been already considered by the model. But in case of this custom equation, you can also write down your own equation. And based on that, you can have a model. So now that important point here is that, let's say I go back to this polynomial. Yes. And if I fit this, so now this whatever I have done just now, it can be represented in the form of this code just by clicking this file here. Here you can find this generate. So if you do that, what you're going to get here is that this total thing what you have done just now, it will be, you can get it over here. So as you can see here that it is also, that's why I was actually discussing about this writing down this function over this MATLAB. So now you can see here that there's some this function is completed, but the outputs are going to be this fit result and that GOF, goodness of fit, as well as this fit results, which is that values of the coefficients of that model what you consider. And as you can see here, the function, the name of the function is create fit, and it is based on the value of this age in the blood pressure. Because when we consider that trying to create a model to understand the fitting of this data set is age of the blood pressure. So we only consider these two variables, this age and the blood pressure. So that's why this is going to be independent. So this is how then I can write it. As you can see that just by plotting this fit result x data and y, we can get this kind of terms. So even without the point here is that even without writing down this code here, you just by just simply just following some like just by going to this app and doing this, going to this card fitting, you can construct this model of this layer models, all of this in MATLAB. So okay, sorry. So until now, so if there is any kind of question, please let me know.
Prithwineel sir, you just shown that using the linear fitting, when you are doing the linear fitting of this given data, I saw in that equation, it was the sign that A star sign of X, it was involved in that equation, right?
Okay, just let me. Here, right?
So instead of polynomial, if it is linear fit, the generating function was A star sign of
Okay, okay. I think that was this interpreter. This one.
here, right. So it should be the linear fitting should be A star X plus B, but it is coming like A star. See that equation, A star sign of X minus phi plus this one, right?
So see, this function is inbuilt actually. Can you repeat your question?
Meaning that the linear fitting means it should be fit that given data by using straight line, right? So like
yes.
It should be like y equals to bx plus c. But it is, I know this is basically inbuilt function, but why MATLAB kept this function like a star sign of x plus b of x plus c? So why that sign of x term has to be involved?
Sorry, I have no idea. So anyway, like maybe it is because of this, like the values of A's and B's and the C's. So what you are getting, or maybe that the goodness of you.
sir,
Yes, yes.
sir, what I'm saying is that as a beginner, I mean, first we have to learn to write the codes, and then only we can move further. And also we need to have the data set.
Yes. Data set you can actually, now you can download it from like Kaggle, you can download it anytime. Too much data set is there.
So please come again, sir. I could not hear you.
So
Data
if you, yes, so if you can okay, let me go back here. So
I mean, these are the prerequisites. First, we need to learn the code, how to write the code
yes,
for very simple ones as a beginner. And then we need to have the requisite data set so that we can try on these kind of plots. I mean,
yes, ma'am. So if you ask me that how it is going to be much more easier, so I think did you realize that I was writing some matrices there?
yes, yes,
Yes, right. So
yes. I was taking the notes also as well.
Yes. So as in case of MATLAB, so whatever data set you are importing, so let me go back there. So if you look into like, I think, is it? Can you see it? This,
So I can see the plot right now. I mean, which is there in the in your screen.
Yes.
The blood pressure versus age, that plot. Yeah,
Yes,
now
sorry.
code part has come.
Okay,
Editor untitled 4, huh?
So in the workspace, as you can see that I have separated these variables.
Yes.
So all of this, like this diabetes is actually the data set what I have downloaded from the internet. Like if you just simply write down that data set for the diabetes treatment, you will find it from the Kaggle as well as from UCI library. You can download it directly from there. So now, why I was giving too much importance towards like matrices, running the matrices system. So this diabetes, as you can see, that this data set is in the form of a matrix. This 768 times 9. Right? So now, let me first just.
And that you have got separated as well. That is why it is showing this 9.
Yes,
Yeah.
exactly. So since the variables I have separated now, so each of them are size 1. The column is now 1. So now only you are going to have only this. Okay, let me go. Like if I go to this age here, you can see that corresponding to age, I have these values. So now I am going to have, I am not in the age column, I am going to have only the ages. No other variables are going to be there. Okay. So now let's say I want to access these informations like that from this age. Okay. So what is the first element of this age? So it is a matrix of the form 768 times 4. So now if I write it down, let me write it down, this age 1, 1, you can see I'm getting the value 50, which was exactly
yes,
the value.
It was 50 only. Yes.
Yes. So this is how you can actually access all the information from the data just by simply writing down this matrix notations. What I did here just now is that if you remember that in the matrix, when I was writing them, just writing down their just indexes like the rows number and the column number, I can access the information from the matrix. So let me write it down one more time here. Like let's say I'm generating a very simple matrix, random matrix, like this. So okay. So I am writing down this very simple A matrix. So now, if I want to access information from this matrix, so let's say I want to know what is the 2th element here. So I can access the information from just by writing down this simple problem. So similarly like that, whenever I am getting to this data set of age in the workspace, just by writing down this matrix comment, I can also access the information. So what I can suggest you is that just you import the data and then just try to check just by writing down these simple matrix comments that whether you can access the data properly or not. Also, here is also one interesting thing here. If you just simply write down the name of the data set in the workspace, it is basically going to give you the total data set. So you can just play with this data set. Like also in the previous lecture, I was talking about that if you have any missing data, how you can replace them with the new number. So all of these things initially you can do just by using simple like matrix comments. So I hope that will not be too much difficult.
Yeah, understood. Now with any two particular column, if I want to take, and suppose I
So
think that one I will be taking as an independent variable X, and then have any relation with the dependent variable Y.
Yes, yes.
So
So
with
like
that, in going in the editor, I can plot.
yes. So just see that I'm just going back to that. Go to this workspace. Click this control button you press, this age, and then let's say you based on the age you want to understand the blood pressure. So now you have selected this. So now if you understand that, if you just try to plot this age and the blood pressure, where you can see that this maybe that x-axis is going to be the age and y-axis is going to be the blood pressure. So what you're going to do is that go to this plot, and let's say you can see that there are many options of plot. Let's say I want to do this scatter. So just if you just click it, you are going to get this time. So this kind of thing, I think you can just simply do
that
it.
can be done.
And as well as if you just look
it
into
is
the
just
code
scattering.
here,
It is not having any relation between Y and X, right?
yes, but it yes, but in another way you are getting like you can see that just but still it is giving me a relationship between them, because like you'll understand that how much they are correlated or not, all of this from this if you select these two values.
Okay, that relation I'm not providing.
No, so that if you use MATLAB, it will automatically can derive it.
It will automatically derive a relation.
Yeah, yes.
Acha, okay. So what as a beginner we can do, like if we can download these kind of data sets. Suppose I will be taking Kishanu's help, okay, and then if we learn to write the small codes, and then I mean the best way to learn is to try out yourself.
Yes,
isn't it?
And that's why I am saying that you write collect a data set, then think it of a matrix and play with it. As well as try to using that separating by those variables, you try to plot them, you try to understand their goodness of it, all of this.
Okay. So separate the variables and then try to plot. Automatically they will take a relation, and also, then give a title to the x-axis, y-axis, and all that stuff.
Exactly. So I think by that time you will be quite familiar with that. Okay.
So let me take, I mean, Kishanu is there, so we can both work it out. And if like we can take a data set and try out the way we have learned, so I think at least one or two things we can do.
Yes, but as I said that at least the pre-processing part, right? That if you can, so just now I show you that this from this age, just by writing down some number, I can find out the value in that table, right? This 50.
Yes, that I understood. Yeah, so that is one.
Yes. So now let's say you want to find out where you don't have any blank entry. So how you can do it? So that is how you try to find out in which position that you are going to have some blank entry. All of this. So this thing, by that, I think if you do that, try to play with that matrix, then I think you will understand it quite nicely.
So suppose like if there is at the number 17, it's a blank.
Yes. So let's say in this case I don't have it. Okay, just let me go back. I have one data set where I have blank entry. So
the one you were showing the last day was probably having one blank.
Yes,
And
yes. So
that you were discussing.
Yes, this CSV.
That was yes, CSV with blank.
So now, as you can see, this entry. Okay, let's just
In,
so this is going to be my 11th row and my second column.
Yes.
So let us first separate the variables. Okay, okay, so now I can separate these variables. Okay. Okay, so if I select it and then separate workspace variables, the variables will be separate. So now if I go to this edge here, I can see in the 11th row.
In is there, yeah.
It means that not a number. So if I write it down here, so edge 11th row in the first column, see, we are getting this. So this is how actually you can try just for beginners, like you can try to do many kind of stuff with this.
And suppose if I do not want to have that in my plot.
Yes.
The blank one I do not want to have in my plot. It should be a continuous one, continuous scattering, and I do not want it there. So is there any way to remove that from this particular 11 row or first column or something like that?
See, today I just now mentioned, if you remember, that in matrix, if I give some value to them, let's say this 11(1), if I assign it some value, let's say I am going to assign it some value, let's say 99.
Okay.
So if I do that now, if you can see, that blank has been replaced by 99.
Oh, acha. Okay, understood.
So this 11 is not it. So this kind of stuff you can do.
No, I have got myself registered in the MATLAB. So next day I think I will try out some.
Yes, you can also try with that online MATLAB. So you just have to log in.
Online one.
Yes. But because you can also install it, because that is going to take at least.
No, online only I'm talking about. I just got my im.edu.in and then the last day I did that. I have registered there. So the next day. And sir, will there, since it's a holiday tomorrow, just generally asking, will there be any class from 4:15 tomorrow?
I think we are going to have 10 on 10th. We are going to have.
I mean, it was 5 days. So what about tomorrow? I mean, tomorrow there is a holiday.
Tomorrow, I think no. 10th we are going to have what class? Then next 2 days, I think I think from IT.
Okay, so we will be having class 10th and then the schedule at 9:30 p.m. exam on 11th, right? Or will you make it 10-1 and take it back to Friday? That's what I was asking.
I think that is Sumanta sir is best person to answer this question.
No, otherwise, if it can be said in the morning meeting, it can be given in the group IM discussion. So we are all checking the group every time. So tomorrow at 4:15 there will be no class as of now. Okay, after the registration, I mean attendance one has come, no? Okay. Okay, thank you, sir. Thank you. Okay, thank you, Prithwineel, sir.
So Sumanta sir, can we now?
Yes, hello.
Yes. So can we?
Yes, I think you can stop the presentation. I think if there is no other question from the participants. Okay, Prithwineel sir, thank you. Then we can end the session.
Thank you, sir. Thank you.
Thank you, madam.